your slope compared to the green line. All right. So that is how you can use both graph, all right, to interpret whether or not you have a competitive inhibitor or the other types of inhibitor, which we'll talk about in a bit. Okay. So if you see a graph like this, right, you would know, okay, this is a competitive inhibitor. Or if you're doing experiments and you are looking at, let's say you plot your initial velocity over substrate concentration, right, and you plot those graphs, and then you are going to now change this, all right, you find your half of km, you find your Vmax, you plot it here, you can find out whether or not the inhibitor is a competitive inhibitor. Okay. Okay. Yeah. Let me see if anybody type anything. Oh. Okay. All right. So that is what we call a competitive inhibitor. Right. Now, there is also another type of inhibitor, which we call non-competitive inhibitor. So the name itself already let you know what type of inhibitor it is. I'm still going to draw my enzymes, guys. I didn't draw the reaction here for you guys, true? For competitive. How do I add a new page? Hold on. Okay. So for the equation of a competitive inhibitor, right? Okay, so for the equation of a competitive inhibitor, it would be the enzyme, the normal reaction, enzyme and substrate, gives you enzyme and substrate. For this one, because we're not really looking at Michaelis Menten, we can include the little product thing if you guys want. I will just do it. Okay, EP, E plus P, right? Now, this is the normal reaction. However, with an inhibitor, okay, with an inhibitor, and usually if we're looking at inhibitor and substrate, we would, because we're adding it, right, we would add the substrate here in the equation. Okay. Oh, that looks ugly. So enzyme, we'll just put the substrate here because we also want to show what happens when we add the inhibitor. Or, right, you can add the inhibitor, okay, and it's going to give you enzyme and the inhibitor complex. Okay, so you can kind of show, all right, the enzymes can go both ways. It can go towards this reaction, and then this, of course, no product, right? No product. Okay. So you can show that no product is made, therefore the velocity of the reaction, right, is slow. Okay, I just wanted to show you this little thing. All right. Now, for non-competitive inhibitor, let me draw our enzyme again. All right. Now, for this non-competitive inhibitor, just like the competitive inhibitor, right? Well, not just like, well, they, all right, they also, all right, make the protein non-functional. However, right, there's a slight difference with the non-competitive inhibitor. Like the name suggests, they do not compete with the substrate. Why? Because somewhere along the surface or within the enzyme somewhere, it has an extra pocket. Okay? There's an extra site which we call the allosteric site. Right? So it's an allosteric site. So therefore it's the allosteric inhibitor. So there is an extra site for the inhibitor. So if this is your substrate, then your inhibitor will bind here, okay? So it doesn't compete for this substrate. However, when the inhibitor binds to the enzyme, forming the enzyme inhibitor complex, what happens is it can render the enzyme non-functional. All right, meaning that the enzyme can no longer, well, do its work. Okay, and so that's uncompetitive inhibitor, right? So even if, let's say, they can still bind to it. So even if it comes and binds, right, to this active site, no product formation occurs. All right. So yeah. So binding of this substrate to this active site, okay. Not substrate, sorry. Binding of this inhibitor to this allosteric site, what happened is it changes the conformation of the enzyme. Although the affinity does not change, meaning the substrate can still come in and form, and they form what we call the enzyme substrate inhibitor complex, right? They will form this complex, but no product will form, okay? So if I would write down the crazy equation, right? Let me write down this equation for you. All right. So if I write down this equation, which is enzyme, right? The enzyme, the substrate, right? Can form enzyme substrate. Okay. I'm just doing the normal one. So always write the new normal one first, and then you can go ahead and tweak it. Okay. So this is a normal one. You can put the plus S too. It's up to you, but it's a little bit misleading sometimes because when you want to add the inhibitor, people might think that the enzyme and the substrate is already together, right? But that's not the case, all right? So hold on. Okay. So what happened is, right? This enzyme can also bind to what? Sorry, guys. I keep on getting interrupted. So the inhibitor can bind to this enzyme, right? And when the inhibitor binds to this enzyme, it can form the enzyme inhibitor complex. And this can also bind with the substrate, okay, forming the enzyme inhibitor substrate. And what happened is no product, okay, no product, right? So they form this strange binding and then no product is formed. So that's a strange part of this thing. All right. Hold on. Yeah. Okay. Now, blah blah blah. Let's go to the graph now. Okay. So this basically renders the enzyme non-functional. All right. So it's going to be slowing down the reaction. Okay. Let us see. Let us see how it goes. All right. So this is V. All right. So, okay. This enzyme inhibitor, this substrate binds. This cannot escape, right? So the substrate binds with the enzyme inhibitor. They're kind of stuck in that place, right? So what happened is that no matter how much substrate you add, okay, because they don't compete for the same active site, the inhibitor will be binding to this allosteric site, and the substrate will bind to the enzyme, right? But when it binds to the enzyme, no reaction occurs. So no matter how much substrate, right, you feed it, it will not give you, or it will not produce a product. Therefore, this reaction cannot reach Vmax. All right? It won't be able to reach Vmax. Okay? But, all right, but what you can see here is, even though, and I think I put EIS, but we usually write ESI. So I'm going to put ESI. Okay. So Vmax decreases. Okay. We can't reach Vmax anymore. Vmax decreases, but what about our Km? So Km is a bit tricky, right? So I'm going to try to explain it. All right. So this complex here that we see, which will help us explain the Km, right? Enzyme substrate inhibitor complex will not dissociate. All right. I don't know why I put this little thing here. Right. It's very hard for them to dissociate. This arrow might be a bit smaller. Okay. So because the enzyme, the inhibitor increases the affinity of everybody. All right. So what happened is enzyme is going to be bounded to the substrate. Now it cannot leave. It is bounded with the inhibitor and the enzyme. So because it cannot leave, the concentration of the enzyme and substrate complex increases. So the enzyme substrate concentration increases. Okay? And the enzyme or the substrate by itself decrease. So Km, right? Just a little reminder. Okay. Right? So now we have more of this and we have less of this. So in a non-competitive inhibitor reaction, all right, the Km decreases. Okay. So the Km decreases and the Vmax decreases. All right. So both of them decrease. Okay. So if we look at the plot, right? So let us have our beaker again, and our beaker will have our substrate and our inhibitor. Right. This will be the one with the inhibitor. Then we have the one with just our substrate. Okay. So the one with just our substrate, the normal plot, right, where it reaches Vmax, okay? However, all right? However, wait, let me draw this better. I need space, so I'm going to draw it better. Oui. Okay, there. All right. So when it comes to the inhibitor one, right? So here is our Vmax for the first reaction without the inhibitor, right? Our Vmax is, oh gosh. Our Vmax is here, well, somewhere there without this line going all over the place. And then our half Vmax will be, of course, half Vmax, right? Now, for our inhibitor, it's not going to reach Vmax. Okay, Vmax is going to decrease. So maybe Vmax is around here, right? So Vmax is going to decrease and our reaction will look something like this. Something like that, I guess. All right. Now, if we're going to look, right, so half of Vmax, so the Vmax for this will be somewhere around here, okay? So this is a Vmax. Let me put it in red. Vmax for the red one. Right? Now, so the Vmax for the reaction without the inhibitor will have a Km of around here, right? For the other one, okay, our Vmax is here, so Km is around here, okay? So Km decreased, right? So this reaction, right, Vmax decrease, Km decrease. You only need a little bit of Km in order to reach Vmax, because I meant Vmax is already low, so yeah, right? Now, when we look at the other plot, let's look at the double reciprocal or Line-Weaver-Burke plot. So if we look at that plot, right, you guys draw it. Usually if we're in class, I'm going to tell you guys to draw it. Okay, so here we have this plot, all right, well, this graph. Now, remember, after lunch? Thank you. Okay, so remember we have, sorry guys, I keep getting interrupted, like I said. All right. So remember that the 1 over Vmax, I should lock this door. I'm not gonna lock my office because if not, well, it's soon over anyway. It's soon over. Okay. Soon 12. Soon time for lunch. Okay. So remember we said that the Vmax is on the y-axis, so 1 over Vmax, right? And the Km is negative 1 over Km. So if the Vmax decrease, and again, you can put your numbers. You can say, you know what, the Vmax for the first one was 10, all right? The second one was 5, okay? That's the Vmax. So we know that if we look at this line, which is 1 over Vmax, all right? We know that the 1 over 10 will be 0.1 and the 1 over 5 will be 0.2. So the 0.2 will be up here, right? Will be higher, okay? Which is the 1 over 5, okay? Which is the lower Vmax, right? And then the higher Vmax, which is 1 divided by 10, will be 0.1, which is lower than that. So the reaction with the without the inhibitor, right? The 1 over Vmax will be here. The reaction with the inhibitor, 1 over Vmax, will be on this y-axis. Okay. The Km will be the same thing, right? I can say, like I said again, I could use the same values. I just want, if you put a value, maybe it'll be easier to understand. You can say this is 10 and this is 5. So the one with the higher, how do you say it? The higher Km, which is this line, the green line. So I'm going to change it back to green. So the one with the higher Km, again, 1 over 10 will be 0.1. So it will be here, right? And the one with the lower Km, all right, which is the 1 over 5, which is 0.2. And remember, this is negative 0.1, negative 0.2. So the plot, all right, so the plot of a non-competitive inhibitor is going to look like this. Okay. Parallel, right? Which makes sense because if we look at the slope, slope is Km, right, divided by Vmax. I always need to remind myself that yes, Km over Vmax, right? So the Km decreased, the Vmax decreased, so the slope should be relatively the same, and so they have a parallel line or somewhat parallel line. All right. So a non-competitive inhibitor will give you this type of plot. Okay. We have one more that I will go through, which is called the wait, guys, I said non-competitive, and oh gosh, I said non-competitive. Sure. Oh, we only have one graph, so that's fine. Hold on. I said non-competitive, but sorry guys, this is uncompetitive. Lol. Always get confused with the two. We'll know the difference when we reach non-competitive. Sorry about that. But this is uncompetitive, right? There's another one called non-competitive, but the big difference between both, they do the same thing. All of this is the same, except of course here. But the non-competitive inhibitor, the enzyme substrate inhibitor complex, is different. All right, it has a different affinity. All right, to the inhibitor, and the substrate and the enzyme have a different affinity for the non-competitive inhibitor. That's the only difference, and because of that difference, the plots look different. All right, but generally it looks the same here, except this, it has an arrow here as well, right? So yes, all right, this is the uncompetitive. We'll talk about the non-competitive. Do I have time? I don't think I have time. Yes, man, I think I have time. All right, I will do it. I don't want to waste your lab session. Okay, so non-competitive is almost the same. All right, so can I like copy this? No, I can't copy this. Okay. So for example, right, I'm just gonna write it again. Okay. Okay, this is your equation. You can have the inhibitor, right? Enzyme inhibitor. You could have a substrate binding to it, enzyme substrate inhibitor. Here the inhibitor can also bind here. Okay. So for a non-competitive inhibitor, it has a little pocket. All right. So this is our inhibitor. This is our substrate. All right. Now, the inhibitor can bind to the enzyme, whether or not the substrate is on the enzyme. Okay. But what happened is, so for example, if the enzyme is already bounded to this substrate, right? Hold on. Let me just double confirm if I really have it the same. Non. Okay. Yeah. It is called non-competitive. Phew. Okay. So enzyme substrate. So basically, even if the enzyme already bound to the substrate, the inhibitor can still come in and form the enzyme substrate inhibitor complex and have no product. Or the enzyme can bind to the inhibitor and the substrate can still bind. Okay, the substrate can still bind to this, right? It's just that it will not form any product. So basically, the main difference, all right, between a non-competitive and a uncompetitive inhibitor is that the substrate is very freely. So what happened here is the substrate can also leave. Okay, this substrate doesn't have to stay in this enzyme inhibitor complex. The substrate can also go or dissociate. Okay, so the substrate can dissociate and associate. So in this case, it is not changing, all right, the affinity of the substrate to the enzyme. Okay, that's not changing. So the substrate can leave whenever it wants, whereas here, right, once the substrate binds to the enzyme inhibitor complex, it is very hard for this substrate to leave. Okay, that's why the Km also decreases. Right. But in this case, because the substrate, right, it can go, it could come, it's just that no product will be formed. It doesn't really affect the Km. So the Km remains the same, all right? Because there will be the same enzyme substrate complex, the concentration of the enzyme to the substrate, and also the free substrate and the free enzyme, right, will not change from whether or not the inhibitor is present. The only thing that changes is that the enzyme is now non-functional. So no matter how much substrate you put in, right, you will not form the product, okay? So in this case, right, in this case, let me okay. In this case, your Vmax also decrease, okay? So Vmax decrease, but Km remains the same, all right? The Km doesn't changes because the dissociation doesn't change, okay? So what you're going to find that you will have a plot. So this is a normal one, normal reaction, okay? Where you reach your Vmax, right? So you have a normal plot, okay? However, when you put in the inhibitor, so the Vmax is going to change. It's going to go to half, right? And so off here. Oops. All right. Something like that. All right. So you see that your Vmax is here. Okay. So half of that is here. That's your Km. All right. Your Vmax is here. Right. And then half of that is somewhere here. I should have drawn this line a little bit more up, closer to this. So half of it could also be the same. Okay, it's supposed to be a little bit more sharper. Give my, there, a little more sharper. All right. So Vmax decreases, but Km is the same, right? And of course, your other plot, okay? Now, Vmax, okay? So your Vmax, let me do my width in the absence, right? The Vmax is going to be higher, but here is 1 over Vmax, so it's going to be at the bottom, okay? With the inhibitor, you have a decrease, all right? So this is going to go up here. Now, Km remains the same. So whether it is the inhibitor or whether it is without inhibitor, it's going to be the same spot. And then you have a plot that looks like this. Oh my gosh. Yeah. Okay. And it makes sense. Again, M is over M equals Km over Vmax. Right? Vmax remains the same. Km remains the same. The only thing is Vmax, which changes, right? And for Vmax, it's going to decrease. So the slope is going to be a bigger number for the reaction with the inhibitor. Okay? So it makes sense if it's here higher up, a little bit more angled, right? But forgive me for my crooked lines, all right? So those are the 3 different types of inhibitor that we'll talk about. There's one more type called mixed inhibitor, but we won't go through that one, all right? And so I think did we go through everything with Michaelis Menten? I think so. I think we did. All right. So this is for introduction to inhibition. I think I show you guys. Yes, we also did Michaelis Menten. Michaelis Menten. Did we do the Michaelis Menten using a different plan? Anyways, next week we're gonna put some examples on the board. You guys are gonna practice for a few minutes before we enter into the new topic. Okay? Now I'm hungry. All right, guys. Any questions? Oh, some people don't left. Wait, don't leave yet. Ah, Jaden and Rosalinda left. Guys, wait. I need to do something.
Miss Rosa had to go and pick up Elise sister from primary school.
You need to pick up your little sister?
No, Rosa had to left to go pick up her little sister from primary school.
Okay. I just wanted to take the, let me check if it sends me. I just wanted to take the attendance. But Jaden and Rosa was here, so okay then. All right, guys. Yes. Oh, you came back. There's 19, only 19 people. Who else never come today? Usually Evan, Jaden, Jamel, Jamian, Javini. Hold on. I need to check. Oh, look at the working on. I mean, free period. What is my attendance sheet now? Well, this is I'll just write down your names. So we have Christian. We have Yanira. We have Delvin. We have Dejanay. We have Edwin. We have Jaden. We have Jamel. We have Jamian, Genevieve, Jaden, Jeremy, Jonathan, Joseph, Natasha, Primily, Rashawn, sorry, and then we have Sil. Okay. All right, guys. Thank you. I will see you guys next week. Goodbye.
Bye,
Have a
Miss.
good weekend.